Well, welcome back. I'm excited to dive in with you this week and take a further look at how we can visualize and summarize data so that we can move from raw numbers to meaningful information. So, as we talked about in our beginning session this week, at times looking at raw data can be frightening and overwhelming. We took a look at the number of heart failure readmissions per facility throughout the United States and saw that it was a long list of numbers that were very difficult to interpret and understand on their own. And it looks something like this. But fortunately, we have our Emory roadmap for data-informed health transformation, and we're going to begin our time together by seeing how the exploration of variables, summarizing them visually and numerically, can help give clarity to understanding that information. So we applied our Emory roadmap in our first session, and we moved from all of those raw data points to a one sample t-test. And we saw how that simple t-test allowed us to compare the differences in the number of heart failure discharges between Colorado and Georgia. And so we moved from a long list of raw numbers to a very simple number, one point of data that's much more intuitive and easy to understand. We'll talk about what that number means as we go through the course, but I just want to illustrate the power of statistics for reducing data, summarizing it, and comparing it. So as you saw, we moved from the yikes, oh my goodness, look at all of these raw numbers, to yay, wow, I can compare Georgia to Colorado using statistics and the roadmap that we've applied. So in our time together in this session, we're going to look at exploring raw data, and we're going to focus on visual tools for comparing raw data. So when we visualize, there are many visual tools that we can use to help move us from yikes to yay. But the three that I'd like to spend our time together today talking about are the histogram, box plot, and scatter plot. So we'll talk a little bit about when to use those, how to actually get that graphic using SPSS, and so what? What do those graphs tell us? So let's begin by looking at a histogram of all of the heart failure discharges in the United States. So in order to generate that histogram, we've opened SPSS, and you can see here we've loaded our data set. We're in the variable view, so you can tell here at the bottom, and we're looking specifically at variable number 18, the heart failure discharges, the total number by facility. So what I'd like you to do is take a moment and either try to generate a histogram on your own, if you like, or review the text and see what a histogram is and what it means. And if with that background knowledge, unpause the recording and come back. Let's take a look at this histogram together. Okay, now that you've taken a look at histograms and what they mean, let's generate one. So if you're in SPSS, you can go to the top menu under Graph. And in your graph, I'd like you to select Chart Builder. The Chart Builder is the one-stop shop for generating the graphs that we'll do this term. It'll give you a warning message to say, are you sure you've defined these variable properties correctly? And for what we're doing in this data set, you're completely fine. So you can tell it OK. And a menu like this will come up. So once you're in this menu, I'd like you to come to the bottom under Gallery. And in the Gallery section is where you choose the type of graphic output that you'd like. We're going to start with a histogram. And now that you've selected histogram from the gallery on the left, I want you to click on the first one, simple histogram. You can double click it, and that will pull that graphical tool into this chart builder area. So with that histogram selected, pulled into the chart building area, we can now go to our list of variables, which are listed here. If they're difficult to read, you can just slide over this bar so that the variable title is more legible. And we're going to select health facility discharge number. That health facility discharge number is going to be placed on the x-axis going horizontally. Generally, in your graphs, the x-axis is for the predictor variable, and the y-axis here is for the outcome variable. That's not relevant for the histograms as much, but you definitely want the variable of interest on the x-axis here for the histogram. Now let's tell it OK and allow it to generate this chart for us. So if you take a look at your SPSS output, here at the bottom we have heart failure discharge numbers. So this is the number of discharges per facility, and the frequency. So how many discharges the facilities are completing. And you can see here certainly the largest number of discharges is somewhere above 650 to 700 if we had to take a guess. And if we follow the bar down, we can see that much fewer than 1,000 facilities have that many discharges. You can see it's very early on in this graph. So just by simply looking at this histogram, we can tell that the majority of facilities here are doing the majority of the discharges. As you can see, on average, we look at the total number of discharges for heart failure across the x-axis. The majority of those are happening in this range, so under 500. So the majority of facilities are discharging under 500 patients for heart failure. So if we apply the normal curve distribution in the black line to these data, we can see that these data are not normally distributed. So with this histogram tool, where we examine one variable at a time, we can see that it does not follow a normal distribution curve. So we started out with a list of raw data on the number of heart failure discharges by facility, which was long and messy and difficult to understand, and we used this histogram tool to understand how those data were distributed. So we certainly have cause to move from yikes to yay with the histogram tool. It's a very simple and intuitive tool to understand. So let's take a look. So let's take a look at another visual tool that you have available to you. These are the box plots. So if we open up SPSS again, we can close the output window, which you have here, or minimize it, whichever you prefer. And this time we're going to look at going back to our graph chart builder we looked at before. We say, okay, we are aware of how the variables need to be configured. And we go to box plot in the gallery. So you can click on it once, and then here it will give you the options of the type of box plots that you can create. Now for the purposes of this example, we're going to create a box plot for a single number. We're going to look at how the scores of heart failure occur across the United States as a whole. So we can either double click on it or drag it up to the preview window. You can see now we need to select the variable that we're going to describe, but since we've already described the total number of heart failure discharges, that variable is by default the one listed. You could certainly come over here and select a different one if you wanted, but for this example, it's not necessary. So now that we've selected it, let's go ahead and tell SPSS, okay, generate this graph for us. So it brings us back to the output window, and this is the graph that it generates. So what I'd like to do is take this graph and look at it in a bit more detail. What does it mean? It's a little bit less intuitive at first glance compared to the histogram, which is in a familiar XY layout. So let's see what this graph tells us. You can see there are several components here. There's this tan box that occupies the center of the graph. This is called a whisker. Sometimes these box plots were called hair and whisker diagrams, and this was considered a whisker, or its outlier, excuse me, indicator of the minimum value in this data set. And then there's a whisker on the top. So we have the central line, a box around it, whiskers, and then in this data set we have quite a few numbers above it. So let's go through and look in a bit of detail about what the box plot tells us. The dark black line in the center of this box is the median. And if we're just to visually take a glance of where this median falls, it's somewhere between 0 and 1,000, and it's in the lower third, so it's somewhere close to 300. We don't know its exact value, but that's approximate. Now let's look at these two green lines, the upper ends of the box. Those are the 25th percentile and the 75th percentile. So 50% of all data fall within these two ends of the box. The lower line, or the lower whisker, is the minimum value, excluding severe outliers, and the upper one is the maximum, excluding severe outliers. And at the top, we have listed a large number of values that are severe outliers. So in this case, we have more outliers that are above 1,000. It's also possible to have many outliers below the minimum value, but in these data, the outliers are 1,000, 1,000 or greater. So now let's take a look at scatter plots. We'll open our SPSS window again so we can generate the graph and move from being overwhelmed by the raw data to celebrating the summary in our graphical display. So let's look at that scatter plot together in SPSS. You'll recognize again that we've gone to our graph window. Now we're going to select the scatter plot, or dot plot it's sometimes called. We can select the one on the top left and drag it up to our preview window. Now one thing that's unique about this graph is that it has an X and a Y axis. So just for the sake of discussion, let's keep the heart failure discharge number as our x-axis, and let's see how this is related to some other variables in our data set. So here we'll select pneumonia discharges, and let's compare how heart failure and pneumonia discharges relate to each other. You can see a pretty strong and powerful relationship here. Let's go ahead and extend that analysis, and this time not simply look at how pneumonia and heart failure compare, but let's look at how heart failure discharges on the x-axis might be related to heart failure readmissions. So we'll select heart failure readmission numbers from our variable list and generate that plot. And we can see here there's an even more powerful linear relationship between the two. So let's look at that in detail. So if we look at the number of heart failure discharges along the bottom and the number of readmissions on the y-axis, you can see a very strong, almost linear relationship between the two, with some notable outliers in the terms of the number of discharges, but it's very consistent with this linear pattern between discharges and readmissions, which is not surprising considering those hospitals who discharge more are more likely to readmit. So with that in mind, I hope you can celebrate the goodness of these visual statistics